Today, we're going to talk about the journey from a service that just works to one that's truly production ready. We're going to explore how you layer on all that good stuff, security, resilience, and automation, that really separates a cool prototype from a system you can actually count on. So let's dive in. This quote just nails it, doesn't it? Getting something to run, that's the minimum. That's just getting in the game. But the real work, the thing that shows true professional engineering, is making that service manageable, reliable, and secure for the long haul. That's the challenge. So to make this all real and not just theory, we're going to follow a case study, a Pi-hole DNS server running in a home lab on Kubernetes. We're going to watch it grow up, basically, through 5 distinct stages of maturity, from a very basic setup to something pretty sophisticated. Okay, so here we are, stage 1, the foundation. At this point, our service is running just fine inside the Kubernetes cluster. But that's the problem. It's completely isolated. So the very first thing we have to do is make it accessible to the rest of the network so it can actually, do its job. So the problem here is a super common one in Kubernetes. By default, services are what's called a cluster IP, which basically means they only have an internal address. They can't be reached from the outside world, which is why our LAN clients couldn't connect. Now the fix? It's surprisingly simple. We just patch the service type to load balancer. And just like that, the service gets exposed on the node's IP address and boom, it's live on the network, ready to go. And right away, this brings us to a huge lesson. The effort to do that was practically zero, a single command. But the risk? It's high. And you have to ask why? Well, because we just fundamentally changed the network perimeter of our cluster. We punched a hole from the local network directly to a service. It's a reminder that sometimes the easiest commands have the biggest blast radius. All right, with the service now out there and exposed, our next priority has to be security. So stage 2 is all about hardening what we've built and, just as importantly, making the underlying architecture a lot more resilient to things going wrong. Okay, this is hardening 101. We've all seen the before state, right? A password just sitting there in plain text, right in the configuration file. It's a massive security risk. The right way, the after state, is to put that password in a Kubernetes secret and then have the deployment reference it. The big idea here is that we've separated the sensitive stuff from the application config. No more accidentally checking passwords into Git. Now, hardening isn't just about the app, it's also about our most critical assets. And in this case, nothing is more critical than the private key for our local certificate authority. This is the root of trust for the whole network. So we treat it like the crown jewels. Move it somewhere safe, lock down the permissions, and make an encrypted offline backup. If this key gets compromised, it's game over for trust on the network. Now let's talk architecture. At first, the Pi-hole was just a middleman, forwarding every request out to the internet. That's a single point of failure. If our internet goes down, so does our DNS. So to build in some resilience, we deployed Unbound, a recursive DNS resolver, right inside the cluster. This means Unbound can often answer queries itself, caching them locally and reducing how much we rely on the outside world. The public resolvers, they're now just our safety net. And this is where the rubber meets the road, where all that preparation pays off. A real incident happened. Alerts started firing, but here's the weird part. DNS queries were still working. In a less mature system, this might cause panic. But here, the process was methodical. We investigated, found a real node outage, and the root cause was a total surprise. Our own firewall hardening was too aggressive and blocked internal cluster traffic. The fix was simple, just reordering the rules. This is what a mature incident response looks like. Calm, methodical, from symptom to fix. Okay, so our system is more secure and it's resilient. Now it's time to level up again. Stage 3 is all about automation, taking humans out of the loop to make the system more reliable, repeatable, and way less prone to error. This is such a classic automation win. We started with a fragile PowerShell script on a single Windows machine to renew certificates. If that machine was off, no more renewals. A disaster waiting to happen. We replaced that entire mess with cert-manager, which is a Kubernetes native tool that handles the entire certificate lifecycle, issuing, renewing, everything, all by itself. It's truly set it and forget it. This whole idea leads us to something even more powerful, GitOps. The concept is pretty simple but profound. Your Git repository becomes the single source of truth, not just for your app code, but for the entire desired state of your infrastructure. Every single change is version controlled, auditable, and reviewed, just like code. So we put this into practice using a tool called Argo CD. Now, our main branch in Git literally defines what the cluster should look like. You commit a change and Argo automatically applies it. But here's the magic part: self-healing. If someone goes and makes a manual change with kubectl, Argo sees that as drift and automatically changes it back to match what's in Git. This makes the system incredibly predictable and reliable. So, now we get to stage 4, the polish. This is where we add those final professional touches that make a system not just functional, but truly maintainable. Let's take an honest look at where the project stands right now. This table gives us a really honest report card. And you can see the big wins, right? Core DNS and certificate automation are at 5 stars. They're absolutely rock solid. But it also shows us exactly where we need to improve. GitOps is up and running, but its scope is still a little narrow, and our observability stack needs better alerting. This is what continuous improvement actually looks like in the real world. And this chart just gives you that same information at a glance. It's a quick gut check. You can immediately see our strengths over on the left and see exactly where our next focus needs to be, making our GitOps and security policy coverage much broader. So let's just step back and look at the whole picture. It's pretty impressive. We've built resilient DNS, automated certificates, policy enforcement, persistent storage with backups, a foundation for GitOps, and a full observability stack. And maybe most importantly, we have 56 detailed operational runbooks. That right there is the hallmark of a system that's truly managed. So after this whole journey, from one little command all the way to a fully featured, resilient system, what's the big takeaway for you, for your own projects? This really says it all. A production-ready system doesn't just appear overnight. It's built layer by layer. You start with something that works, and then you methodically add security, you add resilience, you add automation, and you add that professional polish of great documentation. It's a process. And that brings us to the final question, the one I want to leave you with. For your own projects, your service is running. Great, that's table stakes. But is it managed? And what is your very next single, methodical step on that journey to get there?